Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be walking through the model context protocol, that is MCP. MCP is now very trending these days. Everyone is talking about MCP, MCP servers, MCP client, but what exactly it is? It's still a mystery for many. To rule that out, we'll be deep diving into the MCP, that is Model Context Protocol. So without further delay, let's start. Now, for understanding Model Context Protocol in depth, we'll first have to understand what exactly a context is. We'll understand the context concept and then we'll be slowly moving on to understanding why was there a need for building this MCP protocol. See what exactly is a context in AI or in terms of large language models. So to be very precise, LLMs, whenever we talk about LLMs, we have to provide some input to the LLM. Now that input is termed as a prompt. But when it comes to a rack system or any Gen AI application, we not only consider prompt, with that we'll also have to consider some external factors, or I would say some external data which we give to the LLM so that LLM understands it and provides some insights out of it. So now apart from prompt, whatever we provide to the LLM, we call it as a context. For example, in terms of RAG applications, we retrieve the information from web or from the vector store. Whatever is getting retrieved, that is termed as a context. So context, you can simply call it as a relevant data. It can be documents, it can be databases, APIs, user information, etc. Now, obviously, without any external context that we provide to the LLM, there is no use of it. We will be simply talking with the LLM, which is trained on a specific type of data, or I would say a specific span of data, wherein we would not get some latest informations or trends. For getting that, we'll have to provide it some external context. So I hope the term context is clear to you all. Through this diagram, you can simply see that traditionally LLM was given a prompt and it generates the output from it, which was a limited one because it only contains the data on which it was trained. But now we also provide context with the prompt such that the LLM provides some insightful information which is real time as well as up to date, or it also can be use case specific. So I hope the term context is clear. Based on this term only, this particular protocol is developed. Now let's see step by step what all problem statements, or I would say what all shortcomings we were having in this particular dimension. Now there are multiple approaches. The very early approach was copy paste boilerplate integrations, wherein we were providing these context. Either the developer was copy pasting it manually from some particular source into the prompt. Otherwise, there was something called as a boilerplate template into the prompt itself, which we dynamically pass some variables into the prompt like that. These were the early approaches. So, to give the context, developers used hard coded hacks, for example, paste in JSON, call APIs inside the prompts, or simply embed the data manually. So this was some early approaches where there was no knowledge of function calling or the MCP servers. So earlier we used to do that. For each and every use case, custom code workaround was written. So a lot of manual work, a lot of repetitive work which was not even required, that was done. This is totally brittle and non-scalable at all, because when we come across a multinational company data, we have lots of documents, we have lots of data, we have data in petabytes. So in that case, we won't be manually copy pasting it, we won't be doing some sort of manual work there. So this was entirely scrapped. So this was one of the basic and very early approach, wherein there was some thoughtfulness in this, but yes, it was a lot of manual and a tedious task. So now there was a need for some evolution in this particular field, because this is not going to be working. So that is why companies strived hard and established a concept which is called as function calling or tool calling. Yes, many companies, like for example, OpenAI, introduced this particular concept of function calling, wherein LLM itself will call a function based on the type of query, will execute it, and will get the output and will finalize the results. So, now what happened in this? So, obviously, there was a manual task that was done before. So, to automate this and structure it, function calling or tool calling was introduced. Yes, and I would say this was a great idea at that time. Let me highlight the word at that time. It's not a great idea today. Why is it so? We'll look into that in the upcoming slides. But for now, let's understand function calling or tool calling. Whenever we give a query, let's say we give some sort of sentence as a query to the LLM, or I would say to the pipeline, based on the available tools, or I would say based on the available functions that were defined by the developer itself, the LLM was first giving a JSON output, something like this. You can see the model outputs a structured call like a JSON with some sort of parameters like tool, that is the name of the tool, like get weather, and then the argument list. For example, in this particular get weather function, there is this particular argument that has to be passed, and from the query itself, this particular Mumbai keyword has got extracted and has got outputted as an output from the LLM. So once this output comes from the LLM, this particular function get weather was triggered and was executed at the backend, and whatever output that particular function gives was then again brought to the LLM for further processing. Now, what happens exactly? The client, in this particular case, that is the application, this particular thing executes the function get weather, it gets the result, and then feeds into the model. That is what I already said you. This is better than copy pasting everything manually. Yes, obviously, this is very much a better approach than the previous one. It is thoughtful, but let me tell you, these has some cons. So let me tell you the problem in this particular approach. So the problem was N cross M integrations. Now let me explain you this particular problem. Suppose we have N AI apps. We can also call it as clients, or I would say chatbots, let's say. So we can have N AI apps or agents, and we have some M different tools or services. Now, to be specific, tools or services can be any APIs, it can be any third party stores, or some or anything. So let's say we have N chatbots and M tools. Now let's visualize it as this. We have N agents and we have M number of tools. With the tool calling method that we have discussed earlier, every single app that is the client needs a connector to each tool. Now, for example, in your company, let's say you build three chatbots: app 1, app 2, and app 3. Now, let's say app 1 specifically requires calendar and Gmail. So, what you will be doing is in the app 1, in the client code, you will be adding the function calling. You'll be defining the functions for calling the calendar API or the Gmail API. We'll be writing the functions, you will be defining it inside the client code. Now in app 2, let's say you require calendar and weather. So in app 2 you define a function for calendar and a function for weather. But have you noticed that in app 1 also we require calendar, and in app 2 also we required calendar? It is common, but still we had to write it two times, once in app 1 and once in app 2. We had to define two different times the function calls. So this says that even if you want to use a single tool in three of the applications, you have to hard code it inside the client's tools list. Let's say there is a change in the API structure of calendar, you will have to change it everywhere in app 1, in app 2, and everywhere. You will have to manually check what all function definition changes are there. Accordingly, you'll have to change it. And apart from that, you'll also have to handle the error handling part that you have to define for every single chatbot that you use. So, in short, if I would like to define it, if you have N applications and you have M tools, you will have to create n multiplied by m connectors for every application. Even if the same tool you are using, you will have to define it again and again for every application. So this is a problem. This gives rise to duplication of work and a high maintenance. Every time you'll have to have a check, you will have to keep a check on every single tool definitions. So this is a huge problem that the companies were facing, and because of which there was a need to bring a solution which will rule out this, and because of which MCP was introduced. So this particular MCP, model context protocol, was aimed to convert that n cross m ideology to n plus m ideology. You can see how drastic change, or I would say the how drastic reductions in the number of connectors has got emerged just because of MCP. Now let me tell you what exactly was this great ideology was. MCP stands for Model Context Protocol. It is an open protocol which was developed by Anthropic. So this MCP is often described as USB-C type for AI, a standard port to connect AI with tools or data sources. So as in hardware, we know USB-C type is a common type of connector for connecting different devices. The same way, this particular MCP is termed as USB-C type for the AI. This is this is specifically a standard protocol that has got universally adopted to connect the AI applications with tools or data sources. So the simple ideology is that instead of each app writing connectors, you simply build servers which exposes tools and clients will discover them. Which means that instead of writing the entire tool definition or function definition in every single application or chatbot that you define, we can simply create servers for subsequent application which will expose its tools, and those tools which are exposed by that particular server will then be discovered by the client through large language models. This is the simple ideology. So finally you end up with roughly n plus m work, that is n clients plus m servers. These are nothing but the number of connectors that we will be having instead of n cross m number of connectors. So I hope this particular simple ideology is clear to you all. Even if it is still blurry or unclear, don't worry, we'll be looking into an example in the upcoming slides which will simply clear all your doubts. Now we'll be looking into an overview diagram of MCP which includes the client and the server. So you can see the client side, that is the AI applications. These connects to the MCP server. So this is the simple ideology. Every single chatbot will connect to the MCP server of subsequent domain. Server side will simply expose all the tools, resources, or prompts that it has. Now, for now, just remember tools, resources, and prompts. We are going to look into the upcoming videos when we will be discussing the architecture of MCP. For now, just understand that every single server will expose some set of tools, and those tools will then be discovered by client based on the user query with the help of LLM. And then once those particular set of tools are discovered or identified, then those tools will be executed and the output will be returned to the large language model. So as per the diagram, you can see the client simply discovers the set of tools, external resources, or library or management from the server. So this is a simple, or I would say a high level architecture of MCP. I hope this particular client server architecture of MCP is clear to you all. Don't worry, in detail we'll be looking into it in the upcoming video. So stay tuned for that. Now we'll be looking into a simple example which will clear out every single difference between normal tool calling and using the MCP protocol. What exactly is the difference between them? Let's see through an example. So here goes the example. So traditionally how the tool calling was happening at the client side. Now client side means at the AI application, or I would say chatbot side. So your AI app must define a function, whatever tool you want to define. Your AI app, or I would say the client, must include the function definition. For example, I have defined a simple function, fetch GitHub repo. This particular function takes in a name, repo name, and then it calls and then you just define whatever functionality you have to inside this particular function. May it be authentication, may it be discovery of the uh, GitHub APIs or so. Whatever API definition you want to write, you will be simply writing it inside this particular function. And once you define this particular tool, it will be now ready to be used in that particular AI app. So basically, your AI app will hard code the parameters, API paths, and the error handling. Now, why I have used this particular word hard code? Now, let's say GitHub introduced their API long back that they will include, that they will accept this particular repo name, and based on this repo name, they will provide you the entire repo content. And accordingly, you define this particular function, that the GitHub repo wants this particular repo name, and they will simply return the repo content. That is how you define this particular function. But later on, GitHub decides to change this, to change the schema of the parameters. With the repo name, they also want the auth ID. When this particular thing gets introduced, it will not be automatically changed. It will not be automatically changed in this particular function definition, right? This function definition will simply return an error that auth ID is required. So at that time, the developer will then manually go inside this particular function definition, will change it according to the new latest versions, and then will again deploy it. So isn't this tedious task? This is a hard coded kind of thing, right? So in traditional tool calling, this particular thing happens. You define this particular function based on the user query, the LLM. Since it has an access to these particular function definitions, it will simply create a JSON output, and based on it, the tool will be called and execution will be done. So like that, this traditional tool calling was used to happen. I hope this particular thing is clear. Now, how this particular thing was replaced, or I would say re-innovated by MCP, let's see. So the MCP version includes the logic at the server side itself. How? See, in MCP server, you write this particular thing. Now, note one thing, that this particular thing will be written at the server side only. That means at the GitHub side. GitHub developers will write this particular thing at their end only. Uh, and by any chance, let's say if they don't write, you can also create an MCP server for your use. But once it is constructed, it can then be used in any applications. So see how the tool is getting defined, with the help of the server, with the help of server.tool. Now this server is nothing but the is as per the MCP protocol. This particular server is getting registered, which takes in the arguments as stated by the GitHub MCP server. And then whatever tool definition it includes, you have to write it, and then it returns finally the repo name, the stars, or the description, or any content, basically what it includes. So this particular definition is done on the server side itself. And at the client side, what happens is the AI client doesn't write this particular function at their end. It only does this particular thing. And also this particular thing comes to the client as per the communication protocol. Whenever we use any MCP server, we have to define it in the list of MCP list, which we define in the client side. We have to write a JSON wherein we have to mention the name of the MCP server, we have to mention the description of it, we also have to mention the type of transport, and we have to also write by which method we are accessing that particular MCP server. Once that is done, your client now will be able to access the MCP servers, and with the user's query, it will return this particular JSON, wherein it will include the tool call name, it will include the list of parameters automatically, and this will be called and will be executed, and finally the output will be returned to the LLM. So here the client submits this via MCP protocol, server handles the integration. So you don't have to worry about this. So I hope the difference is getting cleared. In function tool calling, we were defining the logic of the function inside the client side itself, but in MCP, at the server side, we are defining the logic. and this is going to be universal. See, this MCP server, which is created by GitHub itself, can then be used in any number of AI applications, irrespective of the company. If they want to access, they can simply access it with the help of the MCP server that is defined by GitHub. They don't have to manually again and again define tools, write logics and all in the client side. So I hope this thing is clear, and with this example, your all doubts must have got cleared. Similarly, any company it may be, let's say it is Google Drive, let's say it is Tavily, or any other web searching engine, they can define their own MCP server, and we can use it as a client. So this protocol becomes universal. It can be adopted by any client. So I hope this is clear. See some simple benefits that we get from MCP. Why it is considered better than the traditional tool calling. See, separations of concern. So basically client don't need to care about the API details. The logic is not defined by the client, here it is defined by the server. Reusability, this is the most important and the most critical, I would say, aspect of MCP. Many clients can use the same server. They don't have to care about anything about the logics and all. The reusability can be done in any number of AI applications. Scalability, why is it so? Because when you add a new tool, for example Outlook, you build the server logic once. Clients can pick it up. So any number of tool integration is also easy in the list of MCP server. In the client side, you just have to add the JSON part, as I already instructed you before what all information that JSON should contain. If I want to add Outlook MCP server in that, I just have to include a simple small JSON which includes the name, description, transport protocol, and the some extra arguments if necessary. Interoperability, which means standards reduce friction. Why is it so? Because it introduces standards which reduces frictions between the components. So every single component which is present inside the MCP architecture will solely smoothly handle the entire workflow. So these are all the simple benefits through MCP. I know it is still in the growing stage. There are a lot of MCP builders, but still MCP users are less. It is because it is new to the AI era. It will take some time to get emerged successfully. It will take some time to build some security protocols in it. But yes, it is the future. Now let me bring you to some notes, some simple notes which will help you and might clear your doubts which are still left. You still must write the integration logic for each tool, but only once in the server. Yes, if you are building some server, then you have to write it once, but you can use it universally. You can use it any number of times. But if you are using some built-in servers, which are like built-in, which are built by the company itself, then you have no headache. They will simply look about the logic. You just have to use it. You must define the parameter schema, tool name and its arguments in the MCP server. Yes, this is very important because the LLM at the runtime will have an access to these argument list and the description whatever you define inside the function logic as a doc string. It will read that and it will accordingly call the tool. So yes, this definition of parameter list and the description is mandatory. Clients need to understand the tool names, parameter schema via discovery. Yes, you need to make sure that the discovery of the tools and the parameter list is properly handled from the client side. If it is not, then you need to check your pipeline again. Next, you need to note about the version compatibility, error handling, and performance challenges. So yes, all these things you need to make sure about the usage of MCP. But yes, it is powerful and it is going to be the future. So I hope this particular video was informative for you. I hope the concept which was mysterious for you earlier, this concept now has got clear. You are now understanding what exactly MCP is, and you can tell anybody if someone asks you what is MCP. So I hope everything was fruitful. If you guys have any single doubt, then you can straight away put it in the comment section. I'll be happy to solve it. If you have any suggestions or feedbacks, please drop it in the comment section. I'll look at it. For more such videos, do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.